to another episode of Empower Apps. I'm your host, Leo Dian. Today, I'm joined by Marc Schwieterman. Marc, thank you so much for coming on the show.
Hey, Leo, super excited to be here and talking about video stuff with iOS.
Yeah, before we get into Daily and what Daily does, I'll let you go ahead and introduce yourself.
Sure. So I've been in tech for a while. Primarily did kind of back-end stuff in the chemical information industry for quite a while. Grew up on Apple computers, refocused on that around iOS 2 or 3 or something like that. And that's kind of been my primary focus in recent years. Been in a few different places and been at Daily for about 6 months now. I don't know, I really love working on video stuff and just sort of communication technology that helps people connect, as we all saw during the recent events.
Yes. I can imagine. So you're working at right now with Daily. You want to explain what Daily is exactly and what do they do?
Sure. So Daily basically does pretty much anything related to video. So we're a real-time video infrastructure for developers. We offer SDKs both for the browser in the form of Daily.js, and then we have another DailyX library, which we use for mobile SDKs, both for iOS, Android, React Native, Flutter. We also are just about to release a Python library that can be used for AI workflows. We have global mesh infrastructure, so you don't have to deal with like the server side of things for your apps. You can just kind of like get started and start using things immediately. In addition to that, we have low latency video streaming options where you can actually like composite different things and stream those to an audience, both video and voice calls. And we also satisfy a variety of different compliance requirements, such as SOC 2 and like HIPAA, as an example, for like telehealth companies and things of that nature.
Awesome.
So if you have a problem, we have a solution.
Yeah. And I mean, it's a growing thing right now. Now, is it mostly for like meetings or conference calls, essentially?
So you can really build whatever you want. Our systems are built on WebRTC, and we have a product also called Prebuilt, which is something that'll give you kind of like a call experience, where you can have meetings with other people and create rooms, breakout sessions, and stuff like that. But really, we give you the tools to build pretty much anything that you want to related to video.
Okay. I'm asking like if it's like, do you do anything with like live streaming, like Twitch or YouTube or something like that, or is it mostly focused on meetings between one or more, or like two or more people?
We can support that too. That is not my personal area of expertise, but I believe there's like RTMP and similar protocols, and we're compatible with those. So like you could use our services to do a similar broadcast as those. And I'm not positive, but I believe we can also forward things on through other things too. But I would actually have to double check on that.
Yeah. No problem. Cool. So today we wanted to talk about you're kind of the head of the iOS SDK. Or maybe, do you do work on all the SDKs?
So we have like kind of a client team, and there's two of us, myself and another one of my team members, who are primarily focused on the iOS SDK.
Okay.
But we do jump around. Like we have a core layer that we need to work on at times, and so we kind of just jump in wherever needed.
Okay. So let's talk specifically about the iOS SDK. I looked at it. I got to say the documentation is solid, really good stuff out there. And we'll get into that too. But what makes it unique for developing an SDK for iOS, specifically in this like video space?
I would say one thing that makes Daily and our SDKs unique is the team that we have here. We have a variety of people that are very deep in different areas, and so one of the features that we just released in the SDK is adaptive HEVC. And so typically with WebRTC by default, it uses VP8 and software encoding, which will actually like run in your app process. However, with our adaptive HEVC feature, it will actually use the hardware encoders on the device. And that's also what lets us do H.265, which will provide like significantly better video quality with lower bandwidth. And there's there's different characteristics that sort of make it more optimal for delivery and things of that nature. So we have access to those lower level kind of like hardware features that you wouldn't find with more, off-the-shelf solutions. And we'll also, we like helping our customers solve their problems. So if there's something that's like possible and a customer's interested in doing it, like we can usually find a way to make that work for them, and we'll add features and such in support of that.
So I'm curious about like the whole encoding space as far as like what you need to do. Most of the is like because my understanding was HEVC is only Apple, or is it like all platforms support HEVC, or how does that work? And then when you talk about hardware encoding, I assume you mean like the SoC, the A19 or whatever the heck chip we're on. I forgot. A17. A17 is the new one, right? Those have encoders built into the chip itself, correct?
Right. Yes, correct. Yeah. So this is very complicated and there's lots of details. So I'm going to make sure that I get everything aligned right here. But so basically with codecs, typically you have open source versions of things and then closed sourced. Kind of similar to like how with MP3s, there were sort of open source and closed source versions of that provided by different companies. So in the video space, H.264, H.265, those are not open source, but then there are corresponding versions of those. And I'd probably get that wrong. I'm almost certain that like VP8 is the open source version of H.264. It may not actually be the right one. So
Okay.
As far as interoperability goes, with WebRTC, browsers are required to support basically VP8 and H.264.
Okay.
So they have to support all of them. So as long as you support those, you have compatibility. And so then H.265 is not actually supported by most browsers that I am aware of.
Okay.
And so basically, when you stream video, you can have multiple layers. So you can actually have like different encodings, like all in the same stream,
container,
more or less.
Container.
Oh
no, I used the wrong word.
I think container is more of like the file formats.
Gotcha.
I'm not actually. I'm not sure what the exact term would be. But so as one example, you might publish like 3 different quality levels. So if you think of an iOS app, for like little thumbnails, you just need low resolution because you don't need like 720 by 1280, right? Which your phone can't actually publish. If you need to.
Yeah, I know what you mean. Yeah, I let's just say hypothetically, I've gone through and run FFmpeg or YouTube DL, and I'll tell you all the different streams you can get access to. So, yeah, I think that's kind of what you're getting at, is you can get like you can get the WebM, right, or you can get the H.264 or whatever it is off of that. Okay.
Exactly. Okay. So we include basically 2 layers. One that's H.264 for compatibility, so browsers and devices that can actually handle the H.265 can then
step down.
And exactly. And then for H.265 and clients that support it, it will then use that. And so that allows us to have higher quality video images, basically, with less resource consumption.
Okay.
And there's some other features. There's this concept of temporal scalability. And so if you imagine, like, I believe it's every 8. So there's sort of like, imagine 8 frames. You can sort of like drop frames to decrease the frame rate, which then also reduces the bandwidth that's needed.
Yeah.
So broad strokes, H.264, H.265. As far as the encoding, by default, that'll happen in your app. So like if you were to profile it in instruments or something, you would see CPU usage and stuff like that going on in your app process. And then if you use the hardware encoders, which are actually on like Apple's SoCs, that'll actually go out and use the hardware instead of your app process. And if you profile those, you'll see like increased activity in Media Server D, which is like the little process on iOS that manages that. So you're actually kind of like having your video frames like go over to that process and be encoded before they actually then get streamed out.
Nice. So what was there anything new that came out as far as with the Apple event recently, and the new hardware?
Yeah, so I haven't had time to dig into this in detail, but I have seen basically the new iPhone 15 Pros and what is it, the A17 Pro?
Yeah,
I think.
yeah.
The way they're offset always trips me up.
Yep.
But that supposedly actually has an AV1 decoder, and so that's kind of like the successor, like after H.265. Also, H.265 HEVC are basically the same thing.
Okay, okay.
Sometimes use them interchangeably, but so eventually we will have hardware decoding support. Now that's not something we can use on the encoding side yet, but it is interesting to see these things being added. And so in the future, eventually, if we get encoders, then that's something else that we could potentially start leveraging to have even more options.
Right, right. Yeah. Was there anything else you want to talk about when it comes to video encoding and decoding? Or should we talk about the SDK stuff?
I think probably SDK.
All right, let's get into it. So you guys deliver an XC framework, correct? First of all, let's explain what an XC framework is to those who don't know, as far as a mode of delivering a Swift package, so to speak.
Sure. So XC frameworks, I believe, were added with SPM, or at least after SPM became more in use, and so you can package up binary assets, XC framework being one of those, and it lets you combine the platform-specific macho slices for different platforms all into one executable. So you can basically distribute a framework that you could then use in iOS, Mac OS, or like whatever platforms you need to support. And
Okay.
you'll have one slice for each supported platform in that overall framework bundle. So it's kind of like a framework of frameworks.
And it's a binary, right? Because like Swift packages, people
Yes.
think it's just the source code that you import, but you're not doing that. You're doing like an actual binary. What are the advantages of that?
Let's see here. I think for one that you don't have to build it, so like it doesn't add your compilation time. But for us, it's basically a necessity, just because being dependent upon WebRTC, that actually uses an entirely different build system. And so
Okay.
we couldn't create like a completely pure Swift SPM package just because of some of the dependencies that we have to use to build the overall framework.
Okay. That makes total sense. What was the new kind of library that you can build? I'm losing it now. It's like not dynamic and it's not static, but it's the one in between. They mentioned.
The new ones, yeah, on iOS 16. Oh, I forget what it's called too, but yeah, I know what you're talking about. Like,
Yeah.
So there's basically it can be either one, more or less.
Right. Have you looked into that at all? Or is it like is WebRTC, is that like C++, or what is it exactly?
C++.
Okay.
And so WebRTC is developed and maintained by Google, and then the bulk of that is written in C++ for kind of like the core layers of it. But then there are also platform-specific SDKs. So for iOS, then there's additionally Objective-C++
Okay.
on top of that.
Okay. Yeah. What's it called? It's called mergeable libraries. That's what it was
Mergeable
called.
libraries, yes.
Yeah. Because I know they. Go ahead.
Sorry, go ahead.
Well, I was just gonna say I know they added support for C++ this year. In a Swift
I've seen that. I've
Okay.
not had a chance to dig into that yet, but that's something that I'm very interested in. Just because you work with WebRTC and you can use a lot of the classes, but sometimes you need to customize their behavior.
Okay.
But you potentially still need to be able to call C++ code.
Right.
And there's some cases where we've started building like our own sort of replacement for some of those standard types.
Oh, okay.
Haven't needed that yet, but I can see that being useful. And then you have the benefit of like the code you're working on is all Swift, so you're not having to like jump over into other languages quite as often.
I had to
that's
do
something that looks very appealing to me.
a while ago, before I had even a blog post about this, was this like how to like have Swift talk to C++, and I ended up having to create an Objective-C interface in between, and it was a mess. So yeah, that's a nice thing to have.
That's my life. We basically have like a core layer that's Objective-C++, and we actually have some of our core libraries are Rust, and we have to call that, which that's a whole nother thing we could probably talk about for a while. But
so let's talk a little bit about the CI setup. So you guys, I assume, I don't know where your code is stored, but you're using, how are you setting it up so that way your XC framework is built and always tested and things like that?
Sure. So we use GitHub and GitHub Actions, and currently we have some co-located runners basically, and are actually in the process of setting up some images just to make the maintenance of that easier.
Yeah.
And actually, brief tangent, but I noticed that you have something named Bushel
Yes.
that
Yeah.
seems like it's potentially in this space. We've been looking at Tartlet, but I'm just curious: is Bushel intended to be a CI solution or
No,
primarily
it's
local
not.
development?
Tartlet is definitely more of the CI solution. I definitely want to look at. I've gone down that rabbit hole, but no, Bushel is more to run on device, to test your app on device, more so
Okay.
than like a CI solution. For
Okay.
now, for now. So yeah,
So 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 as you probably know, there's like license restrictions and stuff. So you're only allowed to run like two virtual machines like per Mac OS license or something of that nature.
hmm
And at least so far from what I've seen, the hosted runners you can run like two VMs, which works pretty nice.
hmm hmm
So our build system, effectively, we trigger through GitHub Actions, but then we also have to build all of our frameworks, and we need to be able to build all of the languages. So it gets quite complicated.
yeah.
We have some stuff that runs for Android on other hosted runners, and
Okay.
then for iOS stuff, we run the core build. And so basically, we build the core library, which is both WebRTC and Media Soup, C++ and C languages.
Okay.
Then we have the daily core library, which is built in Rust. And that controls, that's kind of like things that we add on top of WebRTC basically to provide additional feature. And then obviously some of these customizations like the adaptive HDVC that we were talking about earlier, that for that we actually had to modify WebRTC itself. So we have kind of our own custom build of that.
Okay.
And then to actually call into Rust code from Swift, you can't. So we use FFI and bindgen basically. So we generate C bindings to our Rust code and then call that from Swift. So
What is that?
yeah, so there's
Yeah. I'm
sorry, go
not
ahead.
familiar with FFI. You want to explain a little bit how that works?
So it's form function interface. If you've ever used a dynamic language like Ruby, you've probably seen this where like you install certain gems and it'll start compiling things.
hmm
And so that's kind of the idea.
Okay.
And so basically it works. It's kind of similar in concept to kind of how Obfusc message send works.
Okay.
Are you familiar with that?
A little bit. Yeah.
So you have like the self pointer and then like a selector, which kind of defines the method that you're going to call, and then some number of arguments.
hmm
And so the way this works is you basically generate C bindings into, in this case, Rust code, and then to invoke that, you have a pointer to that you pass in, which is the thing that you're actually going to invoke the method on, and then additionally pass along some arguments in some other format. And so we have sort of like a serialization format, basically, where we have like a pointer, and then we have a payload that more or less has all the stuff needed to do to make the actual method invocation.
Okay.
So in CI, all that has to be built from scratch and then cleaned, and then at the end of it, packaged up into a framework. So it can get pretty complicated.
Yeah. Okay, let's talk a little bit more about the SDK and the iOS SDK as far as what it provides. So I deep dived into it. It's really great. Like you got a UI kit. Everything's UI kit, and easy to plug in. Where are things at as far as Swift UI is concerned?
So we do support Swift UI. We have a demo app on GitHub, iOS Starter Kit, and that is written in Swift UI. There are not really native view there. So have you had to use like UI view representable, UI view controller representable in those?
Yeah.
Yep. So that's basically what we do currently is we package up some of the WebRTC related views inside of a Swift UI view and then expose it that way.
What are some of the concerns folks should have if they're going to start plugging this SDK? What are some things they should know off the bat that they need to be aware of?
For the most part, things do just work. It is a little bit different. I would say the number one thing with Swift UI, and I'm sure you're familiar with this, but is you need to be conscious of changing state in a way that can cause the views to have to be re-rendered.
Okay.
And so what we recommend basically, our SDK is very robust and we provide a lot of functionality to do different things. And it's often helpful to have sort of like your own domain layer. And so you can kind of like transform things between like the fuller, so at a high level, we have the concept of like a call that you would then join or leave, and then you have participants in the call, and so that's like me, you know, whomever.
Right.
You don't want to like be redrawing your screen if like someone who's not even going to talk like, you know, unmutes something or mutes it again, because you're not actually going to see that.
Right.
And so you want to make sure that you have things structured in a way that is going to be effective for you, and that also gives you sort of like a seam to simplify things. And then have you used the SwiftUI preview canvas much?
Yes. Yep.
Okay, that is probably hands down my favorite feature. Period.
Yeah. Exactly. Yeah.
Have you been able to use SwiftUI much in your own work personally?
Yeah, I do everything in SwiftUI right now.
Okay. Some of the companies I've worked at, we've needed to support UIKit and legacy apps.
Okay.
And so, you know, haven't really been able to use SwiftUI there much. And so I've gotten much deeper in it in probably the past year and a half or so.
Okay.
And I mean, it's the productivity benefits of the preview canvas, different devices, not having to build and run to different screens and like re-navigate, like that is just amazing.
Yes, yes, agreed completely.
So that's why I mentioned creating your own domain. So like using our SDK with SwiftUI, it will all just work, but there are huge benefits both to thinking through like the performance implications of like how you kind of model your own domain, and additionally structuring things so that you can very easily create structs for use in the preview canvas, just to kind of like do your iterative UI development there.
Yep, that makes total sense. Yeah, it reminds me, we just did an episode with Brandon Williams from Point Free, and he was talking about how like keeping things
TCA.
he keeps, you know, keeping stuff separate so that way like you don't have to worry about the video working when you run the SwiftUI preview or simulator, for instance. And like that kind of sounds like what you're talking about with the domain stuff. It's exactly the same concept where you try to keep stuff separated out.
In fact, like I am a huge fan of TCA. Wanted to use it at a previous company, but just couldn't due to like backward support.
Yeah.
I actually built something with Daly's frameworks and TCA as like one of the first things that I did is just kind of like a personal fun project.
Yeah.
The current starter kit that we have up, it doesn't use TCA because I didn't want to use any third-party dependencies, just so that people could to make it more accessible. You know, like you already know the stuff you need to know for Apple development, basically. But I would very much like to port that to TCA. It does a great job of solving all of these sort of like problems that SwiftUI doesn't really have an out-of-the-box solution to. Basically.
Right. Yeah, exactly. So you obviously, if you're in UIKit, you're going to do a lot of delegates and things like that. How's that gone with like transitioning to using more like publishers or async sequences or combine or any of that stuff?
Yes. Mostly good, although we did have sort of a learning experience. So we support, I believe, back to iOS 13.
Oh, wow. Okay.
And 13, it might be 14. I think we may have raised it to 14. But,
okay.
We also want to make sure that, you know, customers in any type of business can use our framework. And so depending on the type of company, they may need to still support UIKit. So we do have a delegate. And for UIKit apps, you know, that's probably a good way to go in some cases. Additionally, we also have published properties. For some of the states. So for example, like call state is a published property currently. So are like participants. We have kind of a big participant struct and that gets published. That can work good if you're doing like an MVVM style UIKit app or in SwiftUI. But the one problem with that is that you can't really create a protocol for something that has like a published property on it.
Right.
Yeah. So if you're wanting to provide like I personally would love to provide, you know, like a first party test double that people can use just so they don't have to write their own, kind of make that easier. With published properties, you can't use that. So
Right.
one change that we plan on making soon is basically switching from published properties to explicit publishers for
Oh,
those, because you
interesting.
can't create
Okay.
a protocol there.
Okay. Yeah, like what I've ended
And
up doing is just like putting a protocol on the thing inside the observed object, and then having the observed object just be whatever the class it's going to be, and then the protocol's inside it, and then the proper the protocol provides whatever you want to provide to the published properties that way. But yeah,
like the properties of the object or value that would be published.
yeah, and then have the protocol
Gotcha.
be like a different implementation for simulator or for
Yep.
whatever. Yeah, but that is, I've heard that problem a lot with a lot of people where they're like, I want to use a published property, and it's like, well, we'll get into the new stuff, but yeah.
Well, and that is, yeah, I would say that that is really interesting, because that's all going to be changing with
Right.
iOS 17. And I personally, like, do you think Combine is here to stay? Because it kind of seems like some of
um
it's going into Swift packages, but I don't know.
uh or you mean to like observation?
Well, so like Combine itself, I think it seems like it was kind of introduced initially in support of Swift UI.
Right.
But then the async await Swift concurrency stuff seems to like largely be superseding it. But there's I believe it's Swift async algorithms
Okay.
package that you can use, and that like similar stuff that you would have with Combine
Right.
publishers is being added to that framework.
So I'll be honest, I haven't deep dived into the excuse me, I haven't deep dived into the async algorithms. More so, I think the observation stuff has really removed a lot of the combined code that I've been doing. In Bushel, for instance, I've talked about this. Like I have one piece of combine right now in Bushel, and that's because it was something that I wrote a year ago that I'm too lazy to migrate over, and it works great. So I think it's more the observation stuff has really made it not necessary. There's things I miss about it for sure, and I like the functional programming aspect, and I think that's kind of what async algorithms provides. But yeah, I mean, is it here to stay? Probably not. But it's not going to go away anytime soon, I would imagine.
I'm very conflicted, because like it kind of took me a while to warm up to Combine. It's kind of a very different model, and I feel like as soon as I started to get my head around it, like
They
Swift
took it away.
concurrency came around,
Yeah.
and then have
Yeah.
you done much with like the async sequences and
Yeah, I have
streams
not
and
done
all that?
anything with async sequences. That's where that's my blind spot is like is this like async sequences and how that replaces combine. I'm much more comfortable with async await when it comes to just the simple like, oh, this is an async call to a network and you get back something. But the async sequence stuff, I'll be honest, that like I had to do something with StoreKit recently, and it was like, okay, I guess this is a for loop, but yeah, it's weird.
Yeah, and just like the sequencing, and there's stuff where like you basically have to use a task group if you don't want things to serialize, and there's
Right,
just
right.
kind of little things that at least aren't always immediately intuitive. I think it's really interesting for SDKs though, because like how do you serve a bunch of customers that have a variety of different needs? And
Yeah, you're kind of screwed, honestly, in a lot of ways. Yeah, because it's like, oh, if you had to serve somebody in iOS 14, like, and I still have some apps like that, and it's like, yeah, good luck trying to do any of that stuff.
where I've kind of settled on, and like so like we have and will continue to have a delegate. I think we're going to replace the published properties with publishers, and that way people that need them can use them, and then probably add in like the async streams at some point.
Okay.
But you can also get those off of publishers, so they're sort of interchangeable, but not exactly.
Yeah, you gotta serve everybody in every space. So I was gonna ask, like, how does observation look to you as far as like as an alternative to published properties? Because I've got all in on observation with Bushel.
Actually, yeah. So I have not used observation a ton.
Which makes sense
I
as an
am
SDK
very excited
developer.
about it for apps. I'm very excited about
Yeah.
it, because what I've seen, at least with Swift UI, is it's very non-intuitive. That like changing something non-visible could cause your entire view tree to re-render.
Yeah.
And so I think that's gonna like basically just solve a lot of that. But I haven't used it enough. Like, can you actually use observable with like to provide like a protocol or for like an interface that you want someone else to use? Have you tried anything like that yet?
No, I haven't. I'm so stuck on using it the way observed objects are that I haven't put my observed objects or my, oh gosh, I knew I was going to say that, observation stuff in a protocol. I still do it the old way where I have a protocol inside the observed object. So, no, I haven't. You probably could. I don't know. I would think it would break the macro, but I could totally be wrong on that. I know I've had weird stuff with macros and Swift data and trying to use protocols in that space. Macros are like, I love them, but you got to be careful because there's stuff you can do with macros that'll break them, and you don't even know until you like deep dive that, oh, this modifies the code this way, that's why it doesn't work. So yeah, it'd be interesting to see if you can go that route.
That expansion feature is just like magical to me, because like, you know, the property wrappers are just kind of opaque, and it's like, you know, we don't necessarily know how these things work, and just being able to see like the actual code is generated.
I think the biggest advantage of macros is just now that we can see how some of the stuff behind the scenes works, and we have access to it. Like you said, property wrappers or codable or any of that stuff that was always like in the compiler that we couldn't understand what was going on. Now we can do that ourselves, which is awesome.
So I don't know that we'll be adopting observation, at least on the API. We'll probably do that like publisher change that I mentioned first, but my plan is basically to update our starter kit app to
starter
use
kit.
them.
That's what I was gonna say. Yeah. Because people are gonna be like, I don't know how to do this with observe. Yeah. Okay.
Exactly. Yeah, I was hoping to do a beta branch, but did not have time to actually do that. But now that, you know, iOS 17 is about to drop, it's about time. So I'll probably be doing that soon. And then I always like to kind of try something first, and then like, you know, take what works and like pull it up. And so probably just use it directly in the app, and then figure out like, okay, can we pull this back into the SDK itself in a way that's helpful, or maybe the app is like the, you know, app layer is like the appropriate place to use that. Right.
Were there any other APIs that were introduced this year that you're like, this is going to be awesome for us at Daily?
Yes. Some of which we can't actually use yet, which is currently frustrating, but I think I found something. So, one thing that's really cool is, have you used continuity camera at all?
Not yet, no. I know what it is. It's like where you can use the iPhone as a camera on a Mac or a TV. Yeah.
Exactly. Yes. Yeah. So there's actually like a third party app named like Camo or something, which sort of provided a way to do this previously. And so continuity camera is kind of Apple's first party version of that. Well, they're now bringing it to tvOS.
Yeah.
Which for video conferencing stuff is really cool, because, you know, you could just sit back and have a conference on your Apple TV and then use your phone as the camera for that.
Yep.
And that totally works. Something we can maybe come back to, although currently it's a bit more difficult to actually get our framework to work on tvOS due to kind of the way that it's built and some of the Rust interactions.
Oh, gotcha. Okay.
But I think we have an approach that will work with that. So that is going to be really cool once we get that working. There's also the addition of, I think it's called UVC. It's like a USB peripheral device for iPad.
Okay.
This is something else I want to explore, but in some cases, I think it's helpful to be able to have like a video conference on like an iPad, and then be able to have potentially like a camera that is not your iPad. Like similar to how you can do a continuity camera, but sort of like an iPad version of that. There's new improved voice processing. So for any of these things where, you know, you're worried about background noise and stuff, that's just sort of going to automatically get better. And then just as a fun thing, iOS 17 is adding, you know, like gesture-based reactions, where it'll just sort of recognize gestures that you do on screen and then do a visual effect.
Yeah.
Have you played with that at all?
No, but I was just thinking about the Apple event and how we can do the double tap, like all these little things that we've gotten from what do you call it, from the Vision Pro. Like Apple's been working on this stuff on the side, and they're just like, here you go. Here's a little something for the iPhone guys can use. Yeah, it's awesome.
So funny thing on that, the watch double tap, I saw that and I was like in awe, and I looked at that and immediately I in my head I could see like the Vision Pro thing when they showed it off, and like the pinch gestures, right?
Right.
It turns out that was like an existing accessibility gesture on watchOS already.
I just released the podcast episode, so we just talked about that. Yeah, totally.
Okay. So you got into that on that. Okay,
yeah.
I will check that out then for the full backstory. So I thought that was fascinating.
Yeah, we just talked about that on the last episode. It was like, do they do all this with assistive touch? Like, yeah, no, totally. Yeah. So, I was gonna ask.
So good.
Okay, they mentioned this. They had a video about it. I don't know if you saw this, and I don't know if you do anything with it. But did you see like the rotating stand thing that they added to the iPhone?
Oh, nightstand or stand something?
No. They had a whole WWDC video about this. Okay, I'm gonna look it up. Sorry. But there's a new API, so you can plug into a USB stand. And
yes, yeah, I did actually see that, and it would let you like remote control it or something like that.
Yeah, what was that called?
I know the video. I think so I've used video conferencing stuff before. I worked at one company remotely, and they would have like cameras in rooms, and you could control them. So if you're trying to like talk to someone, you could like zoom in or zoom out. And yeah, whatever that is, they're I believe now adding support for that. So I'm imagining like a little like iPhone driven like robot or something that can like roam around, and you can like control its like eyes. That would just be something super fun.
I'm trying to look which one it was. If you look up video on the WWDC website, that's not a good idea. Oh, here it is. DocKit. Integrate motorized iPhone stands using DocKit.
That's it. Yeah.
Yeah.
Yep.
Yeah, so yeah, I thought that was interesting. I don't think we've seen any hardware about it yet, but yeah.
That one I saw, and yeah, like I don't actually like, I don't know. I guess I'd kind of like to see if I could get my hands on one of those devices just to play with it,
right?
Because that seems, and you think about a lot of this like AI image recognition stuff is getting really good, and in some cases you don't even need to like use third-party things for that. So like with iOS, how iPad has center stage,
yeah,
and and the Apple Studio
right.
display as well.
Yes.
Basically, you can actually get like the region of interest back from that, so it'll give you like the rectangle, like where faces are, basically. Not so long ago you couldn't do that yourself. Basically, you had to write your own code, but just being able to build like an app or something that uses that, and then would potentially like use DocKit or something to be like, oh, we'll like reorient towards like a person or something interesting that we're trying to like keep an eye on.
Right. Yeah. Exactly. Okay, let's step back. We'll stop talking about the fun stuff, and we'll talk about the nitty gritty.
All right.
So a lot of this, I assume you have to run a lot of this through AV Foundation. How was that experience? What were some curveballs that you got that were just like, wow, this is not what I thought it was going to be? I've done a little bit with AV Foundation, but not a lot. I want to because it's super cool. But kind of give me the lowdown on what it's like doing that experience.
So AV Foundation is very capable. I have kind of played with it in the past. I once actually made a podcast app for basically dropping markers, like audio markers, where you might want to edit
chapters.
Something.
Oh, okay,
yeah. So you can do all this stuff. Well, I guess that was more a core audio feature, but I would kind of consider that part of that umbrella. But you can do virtually anything with it, from like building apps that actually process things offline to doing things live. There's a lot going on there. Basically, with WebRTC specifically, a lot of that is handled for you, but you still have to interact with it, which is kind of strange. So like the two main classes that you use are AV Audio Session, which is a shared global singleton, and then like other apps can also make changes to that.
Okay.
So that is one thing that's tricky. So like when you want to do things like choosing your audio device, you can use the system. I think it's called MP Volume View
Okay.
as one example. So you don't necessarily have to write code to do that, but in some cases you actually do want to.
Okay.
And so, as an example, if you want to override to like always use the speaker instead of like an attached device or something, then you have to get in there and change that session.
Okay.
So we have some code that provides some management of that, but in some cases, like someone building an app might want to manage that directly too, and you still have to deal with that. And you get notifications on a route change, which means any input or output device has changed.
Okay.
Or if like the session is interrupted, like imagine, like you get a phone call or something.
Oh,
The kind of things you might get where like normally like the audio might be ducked or something like that, just to be able to hear it. And so kind of dealing with that is one point of complexity. And then on the video side of things, which is probably what I should have started with, but you have AV capture device, and that's kind of your interface into all of the cameras that you have.
Okay.
And so WebRTC itself supports that directly. And so you can sort of choose between the cameras that you want to use. So like as one example, you could flip between the camera facing you, the user, or the camera on the other side facing the environment.
Gotcha.
And you need to switch between those, and working towards adding support for like continuity camera on TV OS. That's also kind of like you need to use those APIs slightly different because you have to deal with like reconnection.
Okay.
Disappearing on you.
Okay.
The biggest curveball gotcha that I got, which it was actually a learning moment for me, it has to do with video rotation, basically.
Okay.
So you can just use WebRTC out of the box, and it handles device rotation and all that. Question: most of the apps you've worked on, have they supported device rotation?
Probably not, honestly.
Okay.
Yeah.
Okay. On iPad in particular, that's something that you need to deal with just because.
Yeah, iPad,
kind of
but that was like over 10 years ago. So yeah.
Something I've just through coincidence of the things that I've worked on, like most of them have supported rotation, so I'm just kind of like used to that. And,
Okay.
Anyway, so this was the gotcha: is WebRTC, all of that works fine for local video if you use like kind of like the video views that come with it and everything rotates.
Okay.
But if you have an app that doesn't rotate, there's actually an issue with that because it has to rotate the camera like the video that it's sending,
Right.
so that it's still like the right direction on the receiver's screen.
Right.
But on the local device, if the device doesn't rotate with it, it will rotate it anyways, and then it ends up being offset. So to work around that, there's AV capture video preview layer. And so that one you can actually use to preview, the way that you would expect, and then let everything else rotate. And that's actually something that I'll be integrating into our SDK shortly to handle that better.
Okay. Cool. As far as like networking stuff, like actually sending the video out, how does that work?
So we do not have to write code to do that really much at all. WebRTC pretty much
does that for you? Okay.
Yeah, and you basically you just kind of give it the device, and the video frames get passed to WebRTC, and then based on the encodings that you have configured, it'll sort of just be streamed out, and then on the receiving side, like more or less of things will be used, but frames can be dropped. Like WebRTC itself is very resilient, so it can handle packet loss. And then there's a server component called an SFU that also participates in these interactions.
All right, let's jump into future plans. What do you have as far as support for other? Obviously not watchOS. Sorry. I guess unless you're going to show video and kill the battery, I don't think you're going to support watchOS anytime soon. But as far as like, we talked about tvOS, did you want to expand on that at all?
Yeah, so this is kind of where things can get interesting. So WebRTC being C++, you can build it for lots of platforms, and Apple's platform specifically. However, the platforms have different behaviors. And so WebRTC kind of like out of the box has its own like conditional compilation for like Mac OS
Okay.
and UIKit.
Okay.
So you probably know how like the coordinate spaces are flipped as one example.
Right.
But, you know, there's a variety of things that are just kind of like a little bit different. Similar to that, you potentially need to support other platforms too. And with Rust in the mix, we also need to kind of have platform support there. And so in order to build, the way that Rust works is you kind of like you build on a certain platform, and then you can also build for certain targets, but they have to be supported by Rust itself, and they have different tiers of support.
Okay.
The first tier is like it just kind of works, but it doesn't support the standard library, which quite often you need if you're doing anything non-trivial. Tier 2 is then the standard library should work, but it's not like officially supported.
Okay.
So the current state of things right there is basically Rust does now have tier 2 support for tvOS. And so it is possible to build everything with the standard toolchain and have that work.
Okay.
However, it's not actually shipped that way, so you have to set up your own compiler, more or less, like a nightly build to kind of get it working.
Okay.
Vision OS, which I am super excited about,
Yeah, I'd
is
imagine.
not yet supported by Rust. However, have you heard of like Marzipanify? I think that was like maybe Steve Troughton-Smith's project, or there's a few of these
Marzipan,
things. Like,
the code name for Catalyst 100 years ago. Yeah.
yeah, like as an example, like, you know, you have like an ARM64 library that you would like run on a device, and previously, you know, you couldn't run on a Mac until Macs were ARM64 too.
Right.
But then you could, but you still couldn't because it wasn't actually supported. But there is actually a way to go in and like rewrite the macho slices to basically like claim that it supports a platform that it doesn't.
Okay.
And
Yeah.
I've been trying to get that working, but I think that might, because like Rust itself, like the support is really quite similar, and so there's not something functionally different on a lot of these, you know, different chips on different device types. It's just kind of more how things are identified.
Yeah. Have you applied for a developer lab?
No.
Okay. Just thought I'd ask.
I really want to, but like I feel like I need an app for that, and like have not. You mean for Vision OS, right?
Yeah. Yeah.
Did you?
Yeah. No way. No, I'm not flying to California just for that.
No.
Sorry.
Yeah. I think there's one in New York.
I hope so. It would be nice. Yeah. So
yeah, in an ideal world, I want to try to get this kind of rewriting the slices approach working for tvOS and Vision OS.
Okay.
As soon as I do that, I'm going to try to port our app, and then I don't know. I guess it's kind of maybe too late at this point, but I would definitely like to take advantage of that if I can find a good scenario in which it makes sense.
Anything else you want to mention regarding daily or future plans before we close out?
Just, you know, if you're interested in building apps, check us out. We have tons of resources online, lots of educational stuff about WebRTC generally, and, you know, very interested in helping customers build whatever they want to build. So, also, I guess we're just about to release this daily Python SDK, which is really cool. You can just drop this into the various kind of like, you know, like Jupyter Notebook and things of that nature that use Python.
Yep.
You know, just like, you just import it, and you have like working like video stuff that you can run.
That's
like,
awesome.
Right in those things immediately, and you can use it to process video and audio, to do transcription and a variety of other things. So really cool, worth checking out, I think.
Yeah. If you're looking for really good documentation, definitely take a look at what you guys have done at Daily. Really impressive stuff. Great starter kit that gets you going. So definitely take a look at that. Marc, thank you so much for coming on the show. I really appreciate it.
All right, thanks for your time, and I had a lot of fun, Leo. Thank you.
Where can people find you in Daily online?
Daily is daily.co, and for me, I guess if you can spell Schwieterman, just search for Marc Schwieterman, and I'm around. I'm Marc is me on GitHub, MarCisme.
Yep, and we'll put links to that in the show notes in case people don't know how to spell Schwieterman. People can find me on X, I hate that. At Leo G. Dion, I'm a Mastodon at Leo G. Dion at c.im. My company is Bright Digit. Take a look there. There's some new articles coming out about humane code and CI and all sorts of stuff. So thank you so much for joining me for this episode. If you're watching this on YouTube, please like and subscribe. If you are listening to this on a podcast player, I would love a review. If there's something you want to talk about, or there's something you want me to find a guest to talk about, or maybe me to talk about, let me know. I'd love to hear back. Thank you again, and I look forward to talking to you again. Bye, everyone.